Okay, we continue factoring today. Today we're going to cover section 6.4, which is called factor by grouping. Okay, so what you need to start to recognize. You're going to have lots of homework problems where you see the word factor. When you see the word factor, here are the steps you should go through. Number one, the first thing you always look for when you see the word factor is take out the greatest common factor. And we did that last time. And we'll do some more of that again today. So the first thing you always look for whenever you see the word factor is you look for a GCF. Always your first step. The second thing you do is you count the number of terms. If your polynomial has 4 terms, you do something known as factor by grouping, and this is what we're going to do today. So we haven't done that yet. We'll try that in a few minutes here. If your polynomial has 3 terms, then we did some of these yesterday. Not yesterday. Wednesday, whatever the last time we met was. Wednesday. 3 terms. How did we factor if we had 3 terms? We did FOIL backward, didn't we? And that works really well as long as that first coefficient, that leading coefficient, is the number 1. You'll notice all the problems we did the other day, the leading coefficient was always the number 1. So there's 2 possibilities here. Part A. If the leading coefficient equals 1, we use what the book calls trial and error. I can't spell trial correctly. That's not trial, that's trail. How do you spell trial? T-R-I-A-L? Trial and error. I like to call it guess and check. You guess at the answer, and then you do FOIL, and you see if you have the right answer or not. Okay? If your leading coefficient is not 1, you can still use the trial and error method. But we'll see here later today that that's not a very good idea. Well, it is and it isn't. Some people are very good at trial and error. Some people are very good with numbers and very good at guessing and getting the right answer quickly. Most of us are not that way. So if your leading coefficient is not 1, we will again do something called factor by grouping. And again, we'll learn that here in just a few minutes. And finally, if your polynomial only has 2 terms, you will use a special formula. And that's covered in the next section, section 6.5. So we'll end up doing that next week. Okay, but there's the steps you go through. You see the words factor. The first thing you look for is a greatest common factor. Once you're done with your greatest common factor, you count the number of terms left, and depending on how many terms there are, you will do different things. Okay? So let's try this factor by grouping. Factor x cubed plus 2x squared plus 5x minus 10. I'm sorry, plus 5x plus 10. I see the word factor. So the very first thing I do is I look for a common term. Is there a common term in this polynomial? No, there's nothing that's common to all 4 pieces, is there? There's x in 3 of the pieces, but not x in the 4th one. And the numbers, we got a 1, a 2, a 5, and a 10. Nothing common there. So there's no common factor. The next thing we notice is, how many terms are there? There are 4 terms. So when you see 4 terms, you're going to do what's known as factor by grouping. And what that means is, you're going to group the first 2 together, and you're going to group the second 2 together. So you group them in pairs. That's why this is called factor by grouping. You group them in pairs. Look at the first pair, x cubed plus 2x squared. Is there a common term there? Yes, the common term is x squared, so I'm going to factor x squared out. And if I factor x squared out, what's left over? X plus 2. Plus, now I look at my second group. Does my second group have a common term? 5. So I factor the 5 out. Left over is x plus 2. Okay, now, if you've done it correctly, and if factor by grouping is going to work, factor by grouping doesn't always work when you have 4 terms. I don't think we'll see any examples of that today, but you got to believe me. If you've done it correctly, what should happen? Those two things should match perfectly. What if those two things do not match perfectly? Then you did something wrong. That's correct. Those two pieces will match perfectly. Why is it important that those two pieces match perfectly? I'm not going to combine them, but you've got the right idea. What's that? It's not one of my answers, but you're close. Just for a minute, pretend that this polynomial looked like this. X squared times 3 plus 5 times 3. And if I asked you, is there a common factor? Is there a common term there? X squared times 3 and 5 times 3, do those have anything common? Yeah, what do they have common? 3, so I could factor a 3 out, couldn't I? And I would have left over x squared plus 5. This is just like the number 3. I've got an x plus 2 here, and I've got an x plus 2 there. So is there something common to both these pieces connected by this plus sign? Yeah, what's the common thing? X plus 2. So I'm going to write down the x plus 2. Here it is. And when I factor out the x plus 2, when the x plus 2 is gone from each piece, what's left over? X squared plus 5. So now I have factored that polynomial. I factored it because I've got x plus 2 times x squared plus 5. Factoring a polynomial means to write it using multiplication. There it is. I wrote it using multiplication.
Why isn't it? So you did it backwards?
Well, this one isn't really FOIL backwards. But how did I get x squared? Because back up here, when I had x cubed plus 2x squared, what was common with x cubed and 2x squared? X squared was the common thing. Now, if we wanted to check our answer, we could just go ahead and do FOIL and see if we have the right answer. Why don't we do that, just to check our answer? So if I wanted to check, I can still check simply by doing FOIL. What's x times x squared? X to the third. What's x times 5? 5x. What's 2 times x squared? And finally 2 times 5? It's 10. Is it the same as the original problem we started with? Yes, if I rearrange it. If I were to put it in the right order. When you do FOIL this time, it doesn't come out in the right order. That's okay. You could rearrange it and get it in the right order. So when you have 4 terms, you do something called factor by grouping, which is not really FOIL backward. But in order to check your answer, you would go ahead and do FOIL. Let's grab another one here. How about 6x cubed plus 9x squared minus 2x minus 3. Once again, the very first thing I do, I see the word factor. Anytime I see the word factor, I start by looking for a greatest common factor. Is there a greatest common factor? No, I don't think so. 6, 9, 2, and 3, nothing in common with the numbers. And they don't all have an x in them. This last one does not have an x. So no greatest common factor. Now I look, and I see that I have 4 pieces. So what do I do when I have 4 pieces? I factor by grouping. I group them in pairs. So I'm going to write 6x cubed plus 9x squared. That's my first group. And then what? What's my second group? Okay, so you're going to write it as plus negative 2x minus 3. And I think that's a very good way to write it. Okay? I think it's a good idea to always put a plus sign in between. And we'll see why in just a minute. We're going to do this problem again, and I'm going to show you a very common mistake that people make. All right, so I look at my first group. Anything common in my first group?
3x squared.
3x squared is common to both pieces in the first group. So I write down 3x squared. Left over? 2x plus 3. Anything common in the second group? A negative sign, isn't there? All right, in general, when we factor, we like the first thing to be a positive number. We don't like it to be negative. It's okay if it's negative, but what we will normally do is factor out a negative. So I'm going to factor out a negative 1. And where did my plus sign go? What's that? It's gone because if I factor out a negative 1, I'm going to have a positive and a negative. A positive and a negative make a negative. And if I factor out negative 1, what's left over in here? 2x plus 3. So now I look. Does that thing match that thing perfectly? Yes, it does. So that tells me I'm doing it right up to this point. So what's my common thing now? 2x plus 3 would be the common thing. There's a 2x plus 3 in each one. There's one there and one there. And when I take out the 2x plus 3, what's left over? 3x squared minus 1. Questions on that?
So you added the negative 1 because we don't have anything in common?
Correct. The only thing in common was the negative sign. So I factored out the negative sign. In general, we like the first piece to always be positive. So if this has a negative in front of it, I'm always going to factor out a negative and make the first one be positive. Questions on that? Okay, I'm going to do that exact same problem, but I'm going to make a mistake. I'm going to make a mistake on purpose. So we had factor 6x cubed plus 9x squared minus 2x minus 3. Here's what I'll see a lot of people do. First off, they look to see if there's a common factor. There's no common factor. Next thing they'll do is they'll factor by grouping. So they'll write down 6x cubed plus 9x squared minus 2x minus 3. And it looks fine. What's common in the first group? Same thing, 3x squared. And left over? 2x plus 3. Minus. What's common in the second group? Nothing. 2x minus 3. At this point, right now, I should stop and I should tell myself I made a mistake. What tells me that I made a mistake? They are not exactly the same, are they? They're very close, but are they exactly the same? No. One has a plus 3, one has a minus 3. That should tell you you made a mistake.
So I negative 1.
Well, the difference is back up here, actually. If I put the minus sign outside the brackets, it's not wrong to put the minus sign outside the brackets. What is wrong is if I put the minus sign outside the brackets, that sign right there has to change. How come? Because 2 negatives would make a positive, and that's supposed to be a negative 3. Okay? So, you have 2 choices. When you have a minus right here, you've got 2 choices. You put a plus there, and you keep the minus right where it was, which I think is probably the good way to go. Or, You put a minus there, but if you put a minus there, you have to change that sign right there. Because distribute this minus through, I need minus 2x minus 3 to get back to my original thing. So if you're going to put a minus sign outside the parenthesis, that sign and that sign both have to change. So now if that sign changes like it should have, that corrects my mistake. Now I have a 2x plus 3 there and a 2x plus 3 there. They match perfectly. And that's fine. So final answer would still be 2x plus 3, 3x squared minus 1. Again, there's a 1 right there. We don't write it. We're lazy. But there really is a 1 right there. That's where the 3x squared minus 1 came from. Questions on that? Alright, now let's try something like this. Factor. $12w squared minus 19w minus 10. I start exactly the same way. I see the word factor. Anytime I see the word factor, the first thing I look for is a greatest common factor. Is there a greatest common factor for this problem? No, there's nothing that's common to all three pieces, is there? 12, 19, and 10, those numbers don't have anything in common other than the number 1, which doesn't do us any good. I got a W there, I got a W there, but I do not have a W on the end. So there's nothing common. How many pieces are there? 3. There are 3 pieces. And I noticed this time that the leading coefficient is not the number 1. What's the leading coefficient? It's the number 12. So I have 2 choices at this point. My 2 choices are, I can guess and check, or I can use grouping. And let's try the guess and check method first. Okay, so if I were going to do this by guess and check, I would write out my 2 parentheses. And here's where this gets hard. How can I get, when I do my FOIL, how can I get 12w squared in front? Well, I'm going to have a w in each piece, w and w. How can I get the 12? I could use 3 and 4, or I could use 2 and 6, or I could use 12 and 1. Which one's the right one?
3 and 6.
Well, 2 and 6, maybe. 12 and 1? The reality is we have no way of knowing which one is the right one. We simply have to guess. So which one do you want to guess? Do you want to try 12 and 1, 6 and 2, or 4 and 3? 12 and 1. So I'm going to put 12w and w. I simply made a guess. Now I look at the other end. The other end has a negative 10. How can I get negative 10 when I do FOIL? I could use 5 and 2, or I could use 10 and 1. Which one's the right one? 5 and 2? How about signs? Positive 5 and negative 2. Okay, so here's an example of somebody who's very good at factoring, who's very good at the guess and check method. Okay? She got the right answer on the first try. I think. Because if I were to FOIL this out, let's just check and make sure we got the right answer. If I were to check, this would be 12w squared minus 24w plus 5w minus 10. Is that the right answer? I think so, because in the middle, negative 24w plus 5w does give negative 19w. So there's an example of somebody who is a very good guesser. Or very good with numbers. Some people are just very good at looking at numbers and looking at combinations and figuring out how to make it work quickly. How many of you think you would have got that on the first try? Other than lucky who did get it on the first try. What if, just for fun, What if we had made our guess and decided to get the 12W squared, I think you should use 4W and 3W. And then how do you get the 10 on the end? Well, I'm going to guess that you use 5 and 2. Is that the right answer? No, because if you do FOIL, you're going to have 12W squared, and then you would have a 8W and a 15W. Is there any way you can arrange the signs for an 8W and a 15W to make it work out to be negative 19? No. So what does that tell me? That would tell me that I made a bad guess, that that's wrong. And unfortunately, I do not know, is it the 4W and the 3W that's wrong? Or is it the 5 and the 2 that's wrong? I wouldn't know. So what would I have to do? I would have to guess again. So maybe I thought that the only thing wrong was it should be 4W and 2 and 3W and 5. Maybe just moving the numbers will help. Well, again, if I were to try to do FOIL, I would have 12W squared, and then I would have a 20W and a 6W. And again, I would have to ask myself, is there any way I can work out the signs with a 20W and a 6W to get a negative 19 in the middle?
So, I mean,
No.
I feel like I would spend way too much time on this.
I agree. I think most people would spend way too much time doing this. What that would tell me now, this would tell me that the 4W and the 2 and the 3W and the 5 don't work together as a team. So now I would have to decide, is it the 4W and the 3W that are wrong? Maybe I should try 6 and 2. Or maybe I should have used 1 and 10 instead of 2 and 5. And I would have to guess again, and I would have to try. How much time might I spend guessing until I get the right answer?
Too much time.
You might spend way too much time guessing. Like I say, some people are very good at it. Some people can look at numbers and work out the combinations in their head very quickly and get the right answer almost the first time every time. Most of us are not that way. Okay, so here's what most of us are going to do. It's the exact same problem again. Factor. 12W squared minus 19W minus 10. Most of us are going to say, well, there's no greatest common factor. So I'm not going to worry about greatest common factor. I notice I have 3 pieces, and this first number is not the number 1. So here's what we're going to do. We're going to multiply the numbers on the end. We're going to take 12 and multiply by negative 10. How much is 12 times negative 10? Negative 120. You just multiply the 2 numbers on the end. Now, what you need to do, you need to figure out a way to factor the number negative 120 so that when you add the 2 factors, you get the number in the middle, negative 19. So this can be a little bit difficult, but here you're going to use your calculator. Let's see, I can take negative 120 and I can divide it by 2. With a 2 and a negative 60, can I get a negative 19? No. How about negative 120 divided by 3? 3 and a negative 40, negative 19? No. You keep going until you find the right pair. 4 and negative 30, that give me negative 19? No, but I think I'm getting close. 120, oops. Negative 120 divided by 5. Oops. How about a 5 and a negative 24? Can I get negative 19 out of that? Yes. So I'm going to write negative 24 plus 5. Negative 24 plus 5 gives me negative 19. And when I multiply, negative 24 times 5 will give me negative 120. Okay, so I'm going to go back to my original problem here, and I'm going to rewrite it. I'm going to write it as 12W squared. I'm not going to write minus 19W. I'm going to write minus 24W plus 5W. And then the minus 10. So I took the negative 19W here, and I split it into 2 pieces. How does that help me? I now have 4 terms, and when I have 4 terms, I know what to do. When I have 4 terms, I factor by grouping. So I group them. That's 12w squared minus 24w plus 5w minus 10. What's common in the first group? 12w. I take out 12w. Left over? w minus 2. Plus, anything common in the second group? 5. W minus 2 is left over. I'm very sure I'm doing it right because those 2 pieces match perfectly. What if those 2 pieces do not match perfectly? You made a mistake. Go back and try to fix it. My common term is now the w minus 2. And left over? 12w plus 5. What's the advantage of doing it the grouping way? You get it right the first time every time. Unless, of course, you make a mistake along the way. You get it right the first time every time. All right, let's try another one of those. Even though you get the right answer the first time, they are still a bit time consuming, aren't they? Yes, they are. I agree. Factoring when the first number is not the number 1 is not always real easy. Okay, how about 6x squared plus 9x minus 60? How would you start? Nope, you wouldn't start by multiplying the front by the back. First thing you always look for is a greatest common factor. Is there a greatest common factor? Yes, the greatest common factor is 3. So you always pull out the greatest common factor first. Left over is 2x squared plus 3x minus 20. Okay, now here's what I like to do on these. This is my personal opinion. I know when I get done, my answer is going to look like this. I'm going to have a 3, and then I'm going to have a set of things like that. And what I like to do is I like to go off to the side and figure out what the 2 sets of things are. So I'm just going to go off to the side over here, and I'm going to deal with the 2x squared plus 3x minus 20. Now I notice there's no common factor. So now I multiply the ends. What's 2 times negative 20? Negative 40. 2 times negative 20 is negative 40. I need to break up negative 40 so that my 2 numbers add up to be the number 3. How can you break up the number 40 to get the number 3 in the middle? What's that? So I want a positive 8 and a negative 5. Negative 5 times 8 would give me negative 40, and negative 5 plus 8 does give me 3. I think there's the correct way to do it. Negative 5 and positive 8. So once again, what we do, we take the 3 in the middle, and we split the 3 into the middle into 2 different pieces. So we're going to write this as 2x squared minus 5x plus 8x minus 20. Group them. That's 2x squared minus 5x plus 8x minus 20. What's common in the first group? The only thing common is the letter x. And when you take the x out, what's left over? 2x minus 5. Plus, anything common in the second group? 4. Left over? 2x minus 5. Do my bracket things match up exactly? Yes, then I'm doing it right. So I'm going to have 2x minus 5, and what would be left over? X plus 4. So now I go back to my original problem, and I fill in for my final answer. So for my original problem, my final answer is going to have that 3, and then it's going to have 2x minus 5, and then x plus 4. This is as big as it gets, yep. So I would agree with you, these are not easy problems. When you have a trinomial and you do not have the number 1 right there, like in this case we have the number 6, factoring is not easy. I will completely agree with you. Questions on that?
How could they know, like if I look at that 6x for the first time, I would think it would be the one. If I looking at it, I would think it would be like the one where you have to have it add in the middle one.
Well, that's what we have eventually. I mean, what we have here is if you do FOIL here, they would add to be the number 3, but then you multiply by that 3, you do get the 9. And again, you could try it. I mean, you could take 6x squared plus 9x minus 60. Again, the first thing you always do is pull out the common term. And then you could say, well, look, I've got 3 pieces left. So I know it should look like this. And this one I don't think would be so bad by doing the guessing way, because you've got to have a 2x squared in front. What's the only way you can get a 2x squared in front? It would have to be a 2x and an x. So this one's not so bad by guessing because there's not so many guesses you have to deal with. And then you look at the other number, you've got a 20 on the end. How could you get a 20 on the end? You could do 5 and 4. You could do 2 and 10. You could do 20 and 1. So you'd have some guesses there. It might take you a little time, but I think after a little bit, you would find that the -5 and the +4 work because you do FOIL, you work it out, you do get the +3 in the middle. So that one's not a horrible one to do by guessing. If the first number is prime, then the guessing method is not so bad because there's only one way that can work. If the first number is not prime, then the guessing way can be very difficult because there's lots of options for your first one, lots of options for your last one.